So now we can make use of the extreme value theorem and the second theorem that we just introduced above to establish a method for identifying absolute extrema on specifically closed intervals. So for this process to work, what we're going to specifically need to make sure we have met is a function that we are restricting to some specific closed domain. So this method won't apply for a function that we're considering for all values of x if either of those intervals is open. So if we had something like rounded parenthesis a to b or close bracket a rounded parenthesis b. So if our function's defined on an interval that looks like one of those, doesn't work if we're looking at negative infinity, positive infinity. So we need to make sure this is a closed interval from a to b, any two real numbers. So our method for finding absolute extreme in a case like this is to first verify that our function is continuous on that closed interval. We then want to find all critical values for our function. And again, critical values occur whenever the first derivative is equal to 0 or the first derivative is undefined or does not exist. We need to evaluate the function at the two endpoints. So that means evaluate it at A and evaluate it at B, and then evaluate it for any critical values. And then we just look at those different results. We identify which one is the largest. So the absolute maximum is just going to be the largest of those results. And the minimum, the absolute minimum, is going to be the smallest of those results.